I'm going to be reducing the number of coefficients in a low-pass filter. This will of course have an impact on its quality measures, and I'll attempt to use Slifer features to restore some of that quality. Here's Slifer. I bring in a sessions file from previous runs, and in will come now a 101 coefficient low-pass filter. Here's side lobe level of about minus 70 dB here. I'm going to be quite precise about this so that I can make subsequent comparisons. I'm going to do a quality measure on it, and there's showing the 70 dB. I'm going to be particularly interested in this feature here, transition width of 345. I'm going to try to preserve that if possible. First, I'm going to also consider what I should want for my target profile. I'm going to change it from this brick wall thing, which is originally here shown in red. I'm going to promote the actual yellow curve to be a red curve. I'm going to promote the filter's magnitude to be now my upcoming target profile. You can see it's underneath there. It's red, and I'm going to hit this very, very hardly. I'm going to lose 51 coefficients, and this now is the filter I've got. You notice I've far from having 70 dB, I've nosed up here quite high on my side lobe levels. I'm going to take it as a goal to arrange to get some modest improvement in this situation. Try to bring down these side lobes below 40 dB. I'm not going to pay too much attention to the passband ripple. That's pretty low anyway. Even after cutting it that much, we probably will assume we can live with that. And I'm going to try to do these changes, particularly to the side lobes here, while preserving, or perhaps even if possible improving, the transition width here. I'm going to dial in something which I like to do here. I like to bring in the error. There's a real error curve. Here it is in the Cameo, and I toggle it up to here. Now I'm able to make movements on the error directly, and that might be useful, although I'm keeping my dB plot down here. So here, as we can see, is a fair amount of ripple, although still not terribly large up in this area. But of course I haven't done anything to the side lobe level. Now, one of the important things of frequency sampling is to take the transition samples and try to use those to lower the sideband level. So I'm just going to go down vertically, as is the case with standard frequency sampling, and you can see that it's not doing too well here. I'm sometimes bringing the side lobes up, sometimes bringing them down. Let me use this sample as well to see what effect I can get with that. Now I've managed to get my side lobes all below 40 dB. You can bet, however, that we've increased the transition width, probably, because we see that the yellow one has moved quite far away from the red one. Let's just refresh our memory. We were hoping that it would be 345 or better. Let's just measure it just for kicks, and we find, well, in fact, we haven't done worse at all. We've actually kept it below the 345, and we've now got the side lobe level down to 42. We could attempt to do other things, like, for example, try to move these passband samples so as to minimize the error here, this ripple here in the passband, if we should wish to. But if we're not careful, changes even in the passband will reflect as changes out in the stopband, and we might not be all that happy with the result. Notice that we're dealing here with error in the upper curve, and we can adjust the error not only vertically, but if we should wish to, we can come and follow the target. That will be, in this case, to move along the horizontal line here, and we find that we can make some movements this way, which will moreover have effects. Might could live with a bit more ripple back here, and maybe try to close up the transition band a little bit more even. So let's have a look at that one. And in that case, we've got 308, which is a slightly better transition width. We've still got the dB down below 41. So pretty good day's work on this. We've restored the transition width. we have lived with a compromise in our original side lobe level, and we've not paid much attention to the ripple in the passband, although of course inevitably that has been impacted as well.